In this example, we continue the previous one by doing a simplification of the expression of a function, but now we will do it as a product of sums instead of a sum of products. So this is the function giving us the list of minterms. I can put them in the map. So if I want a product of sums, I start by simplifying, starting with the max terms. Max terms. So I look at the places where the function is equal to 0, and then I will obtain a minimal product of sum. Okay, is the dual procedure to the using the minterms. Okay, so because I need the zeros now, I will make them explicit, and the whole process is exactly the same as we do with the minterms, but now I do with the max terms. I now just have to find the zero implicants, the implicants using zeros, and then we have to take care to convert those implicants to the expressions they represent. But now I just use the zeros and I do the same thing. If I start with this 0, for example, this has an adjacent 0 here, I have a first order implicant here. Now I check all around. On the left I don't have zeros, on the bottom I don't have them, but on the top is this row I have them. So this is a implicant. Okay, I check again if I have the adjacent implicant. It will be here and here. I don't have it, so I cannot simplify it anymore. This is a prime implicant of zeros. More implicants of zeros. If I start with this 0, for example, this is a implicant, and on the right I have another implicant, okay, of zeros. So all these 4 are an implicant of zeros. I don't have one adjacent on the top, not on the bottom, so this is also a prime implicant of zeros. Okay, but if you see, starting from this implicant here, I have another adjacent here. I have another order 2 implicant. I don't have one on the right, not one on the top, so it's also another possible prime implicant. Okay. So the idea is to find out all possible prime implicants, no matter if the zeros are already covered by another prime implicant. We need to know all of them so that in the second phase of the process we can choose the best to build our function. Okay, so now this 0 here, it's adjacent to this one. I have an implicant here. I don't have the one on the top. I don't have one on the right, don't have one on the left, so this is another prime implicant. And as far as I can see, I think there are no more prime implicants in the map. Okay. So again, these zeros are only covered by one prime implicant, so this prime implicant will be essential. This one as well, this will be essential to cover this max term. This prime implicant will be essential to cover this max term here. So this prime implicant we have here is not essential, and actually it's not necessary because these zeros are already covered by this prime implicant that is essential, and these zeros are already covered by this prime implicant. Okay, so we will only need this one, and this to build the minimal expression for the function. Now, the point here is what expression corresponds to these prime implicants. Now, these are implicants of zeros, so I'm looking for some expression that is 0 in these cases. For example, here and here, these 4 cases. This is the expression that is 0 when a is 1. Okay, so A is going to appear, and for the sum to be 0 when A is 1, it needs to be complemented. Okay, this is also 0 when C or when D is 0. Okay, D is 0 in all the cases. Okay, but B, no matter what the value has, because it can be 1 or 0, so it means it will not appear in the expression. Or C can be 0 or 1, so it will not appear in the expression. But D will appear. It's 0 when D is 0. So this is not complemented. If you see when A is 1 and D is 0, it will become 0 plus 0, and the term will be 0. So the difference with the implicants of 1s is that in this case, when the variable is a 1 will appear complemented in the expression. When the variable is a 0, it will appear not complemented. Okay. So in the same way, I can find which are the corresponding expressions for the other prime implicants. This is the one that is 0 when A is 0. When B is 1, so B will be complemented. When C is whatever value, so it will not appear, and when D is 1, so it will also be complemented. Okay. And now the last one, this implicant here, will be 0 when A is 0 and when C is 1, and the other variables will not appear. So the minimal expression for my function will simply be the product of all these sum terms. A complemented plus D, A plus B complemented plus D complemented, A plus C complemented. Okay. So this way, from the previous example, we have the minimal expression of the sum of product, and also this was one of the possible minimal expressions. We have two alternatives here. We decided to use one of them, and here we have the minimal expression as a product of sums. In this case, we have no alternatives, okay, because there are three prime implicants. The three are essential, so we have to use the three of them, and we don't need any additional prime implicants. Okay, so this will be the minimal product of sums for the function. That's it. Thank you.